Masudi here.
Hi guys, this is Imo from SOD.
Last session we refactored, I remember we refactored the admin side. We wrote the first version of the server that accepted a callback for, for the new incoming connection, and it kind of hid all the complexity of, connecting and serializing and deserializing the data, to the customer, to the client. But the customer part, refactoring the customer, is still remaining, and also it is not correct because the first problem is that it is creating a single connection at the start of the program, and to the end it just uses the first connection to send command and receive the response. But as we said before, the best way is to create a new connection for each request and get the response and then close the connection, and the server has this while true loop that is listening for the incoming connection, and the server now accepts as many as it receives the connections, but the customer, the client part is only issuing a single connection. So that is the first thing that we should refactor. The second thing is that we should follow the protocol that the server is imposing. The server is saying that I will take the message. So the request, yes, the message is a serialized sequence of serialized bytes, and the server interprets as, it listens for the incoming bytes until the first \n character, until the byte that the value of the byte is 10. I think the 10 byte with 10 is the \n. And when it sees the \n, it takes all the bytes that has received as the command, and then it continues getting the rest of the bytes until it sees two consecutive \n's, and then it takes the rest as the body. And as I recall, last session we wrote these two println that were printing the command and body, because the server, we are here just saying notify me on new connection, and the rest of the complexity is hidden behind the scenes, by the server. And it composes a request object and passes to us. And from there, in the request, we have the command, and let me see, the body, the command, and the parameters. And then we have to return a response, an object, which will have the command, the status, and the body. And this is the responsibility of the server to again serialize it and send it to the other side. But the customer should also follow the protocol of the server as well, and the customer should also, because as before, as we have left it as before, it is appending an @ sign to the end of the message as an indicator of the end of the message, but the @ sign is not the end of the message indicator anymore. The two consecutive \n's, and later you'll see why two consecutive \n, because I'm just step by step I'm trying to
Make it better.
yes make it like HTTP and then switch it to the HTTP protocol. I'll show you the HTTP protocol maybe in this session, maybe the next session. Okay, so let's say for each request, let's say we have let me create another package for the client, because we have the admin. Let's have the customer package, and in the customer package we have to have something like HTTP. No, sorry, this is not HTTP. I don't know what to name the protocol that we have. So
Our protocol, MassOD protocol.
yes, we can name it that. But we have this request and response. We want to write some class just for accepting requests, serializing the request, making connection, and then deserializing the response, and then sending the response to the other, like the vice versa of the server in this side.
That's a kind of connection.
Yes. So let's name it connector. and this connector class will accept, let's say it will have a function, send function, that will accept the request. This request is the one that we have written here. We have to, move it to, because it's not dedicated to the admin. We can later move it to a better named package. So this send will send a request and will return a response. But returning a response, let's just put it like this. Returning a response synchronously is not possible because it will keep the customer side waiting. And when we write the GUI, graphical user interface, you'll see that this is not possible to keep the application waiting, for example, for 10 seconds to get the response back. We have to again switch to the callback mechanism, like the one we had in the server side. But for the moment, we can go with this, way, with this path. So, so instead of this socket here, we will have val connector, two ends, connector, and we will create an object of the connector. And now that we have an object of the connector, let me move it outside of the main, put it here. And then from there, when we, for example, want to issue a request to the other side, for example, ask for product list, we don't want to be, we don't want to know anything about the input stream and output stream of the socket, or if there is any socket, in between. We just want to
make a connection.
Not connection. We just want to pass our request to the connector, and then it is the job of the connector to issue the request, the way it sees fit. For example, the connector may, may use the HTTP protocol because the connector knows that the server side is supporting the HTTP.
Someone else is responsible for this. Serializing and
deserializing the messages. So placing the order, then we don't need this input stream and output stream. For placing the order, we have to just create a request. Let me just create it at the end here. So listen for admin. No, we don't want to listen. We don't want to know anything about that. Val request equals request. So we create a request. The request will have a command. The command will be place order and empty parameters. We don't have any parameters, and the body will be the order itself, order. And I'm going to delete the command from here because we are now sending the command, we are giving it to the request, and the body, we are giving them separated. We are passing them separated. So let's say the order, and we don't need to append any @ sign at the end because here we don't have to know anything about the underlying protocol, because if we know here, if we are supposed to know that, we have to append the @ sign in order to make the server to know, for example, that is the end of our message. Then we will also be, overwhelmed, or it is not our responsibility here.
Request should connector should do whole steps. Yes,
of course. Now we pass, as you said, we pass this request to the connector. So we say connector.send request and request, and then we get a response, of course, an HTTP not HTTP, response. And then here we have the response, and we can say, for example, we can print ln that response was, for example, response dot body, or let's say status and body. Response dot body. As you remember, like this, before we had to say listen for a response for admin after writing, serializing and writing to this stream. We were then listening until an @ sign. But now we are not, we don't need this. We don't need this part. Let's get rid of that. And we We have only to focus on our, on the customer business. The customer business is sending requests, and we don't want to be forced to know anything about how it is being done. So ask for product list, place order, and ask for product list is, we have to get rid of these streams. So for asking for product list,
Connector.
we are just creating a request equals request, which has this command get product list, and the body is not important, but let's just send this message as body just to see that the body is also being sent to the other side. Okay, and again for sending we have to pass it to, let me just copy and paste this part because this bit is the same. For sending the request we are passing it to the connector. So the customer is done here. We don't need these imports anymore, the stream and socket. We can get rid of them. And now let's go and write this part, the connector part. So when the connector receives a request, then it has to create a client, a socket. Let's say socket equals socket, and this socket will have the address, the local host, or we can pass, for example, 127.0.0.1 as the loopback address, because because we know that the server is in the same machine and we are giving the address of the same machine, and we also have to give the port as the process which is listening, acting as the server. So for each request we will try to connect through a socket to the server, and after the connection is made, then we get the in stream of the socket, get input stream, and also we will get the out stream, socket dot out stream, get out stream. And now we have to first serialize the request and send it to the other side, and then wait for the response and create a response object and return from this function. So first let's serialize in stream dot outstream dot write. We are going to write the message, the serialized message will be like this: serialized request equals will be let's say request. I'm creating a string with request dot command, then a \n. I'm following the protocol that the server expecting us to do.
It's waiting for us.
The server expects us to send the command, then a \n, and then the body, and then 2 consecutive \n's. So then the request body, request dot body, and then 2 \n. So this, and then we get the byte array. We convert it to a sequence of bytes. We convert this string which we have created, concatenated, all that. We, by this function, to byte array, we are you can see that I can here it is inferring the type, but it's not showing anymore byte array. We are converting it because in order to send it to the other side, we have to convert our stuff to a sequence of bytes. For example, if it is an integer, it is 4 consecutive bytes. We have to first convert it to a byte array which contains those 4 bytes, and then send it to the other side. And then the other side has to receive those bytes, 4 consecutive bytes, and then try to convert it to an integer again. Okay, so we send the serialized request. Then we try to get the response. And the response here, let's see how the server is sending the response.
Status and body.
Yes, it is writing this, sending to the client first the status, then a backslash n, then the body, but there is no,
Nothing to, as a contraction to
yes,
show that is the end of that.
nothing as the end indicator of the end of the message. Yes, we don't have anything like that. We can add a special character, or we can take a special byte as the end, or we can take again 2 consecutive backslash n as the end of the response.
But it didn't make any problem when there wasn't any.
No, because no.
Because there wasn't any connector.
Yes. No, we were able to send the request, but when we were trying to get the response, all those weird
yes.
characters
remember.
were
Okay.
printing. Yes.
I thought that was because the @ sign character. It was waiting for the @ sign, but
No.
there wasn't any @ sign.
No. First, we tried to make this part work, the server side, and we left the customer side to the session.
Okay, I got it.
So 2 backslash n like this, we have to create something like this that will get. I can copy and paste this and try to make it work on the other side, because this bit of work is the interpreter, is acting as the interpreter of the protocol. It is trying to detect where it sees the backslash n or 2 consecutive backslash n's. So I copy and paste it to this side, and let's make it a function, because it will be better. Let's say this function will be fun receive response, and this receive response will return a response, and I paste it here. We will refactor it later, and this send will first call the receive response, and receive response, and it will return the response that, so it has to pass the input stream, of course. In stream, input stream. So we send the in stream. Here we don't need this part, not this part. Okay, and new line has seen, command is seen. Then this is not the command anymore, is status, I think. So with the response we are sending, let me see. First we are sending the status and then the body, not the command. So in the connector we have to say no, the status is seen. Status is seen. We don't have command, we have the body. So first we see the first backslash n. So this should be status, not until the first backslash n. It will be interpreted as status. Then it will be the body. Then we have all the things that we need, the status and the body. So now we can return. I think we are lacking a brace here. Yes. Okay. Now we have to return the response, which we have the command. Command is, of course.
Body.
No. We have in the request. We have the command in the request. So let's also receive the request here, because command is inside the request. Request. Okay. Request dot command, and then as the status we have it status, but it is not int, it is string. We can convert it to
string,
int. Yes, to int. And what's wrong with it? So we can get it outside of the while loop, because it's the inner scope and not visible. So we are calling the toInt function on a string, which will try to convert the string to an integer, and if it fails, it will throw an exception. So because we are 100% sure that it will be an integer, all the characters will be digit, so it is safe. And as the body, we have the body, of course, and let's see, unreachable code. Why? We have 2 while loops. No need for 2 while here because the first one there was for accepting more connections. We don't need the first while loop. So message so far. Okay. It seems fine to me. Connector send, and let's see if
Test it.
Yes, let's put it to test. So this is the customer. If you look at the customer, you see nothing about the underlying protocol or streams or sockets. You see anything. You just see a connector which accepts a request. And all we have to do is to create a request object. And then we receive a response object. So let's run the admin first. Okay, it's running. Let's run the customer. And let's, for example, ask for product list 1. Okay, we are receiving the product list. We weren't able to receive before. We are receiving the response was 1 apple
500
equals 500, orange equals 200, and like this. And I don't know what this 1 is here. And then we are printing the customer main menu. And
that is the status, yes?
Oh, yes. This 1 is the status, yes. In the admin side, we have get product list and get me all product please. Because if we go to the admin, you can see here that we have 2 print lns here that we were using it as, test it. Try to see if actually the command in the body is being received correctly. And so let's also, again, ask for product list. It's working. And also this part. And because it is creating a new request, a new socket connection for each request we are sending. So let's place an order. Enter product name, for example, apple, amount for yes, and orange, 10, and no. Okay, response was 1, order was placed. So if we go to the other side, we can see that it received apple 4, orange 10, and then the order was apple 4, orange 10. It's, we are not serializing the response correctly. We are using pipes, here we don't have pipe here, but the whole message is being sent and received correctly. The protocol that we have until here, the \n and 2 consecutive \n as the indicator of the request and the response is working. Yes, is working. And as you can see, we are sending, we are creating a new socket connection for each request, and then we are receiving the response, and then we are closing the connection. And as you'll see later, this is the way that all the connections that all around you, the HTTP connections that is being made is working. That's the way. So I think this is enough for this session. We also refactored the customer, and you can see that the admin here has only this server and is receiving requests, and then it sends response. And also the customer part has this connector and sends requests and receives the responses. And they are all refactored. The socket part is being refactored and is being extracted to a separate class, 2 separate classes, the logic of all connections and all that stuff. Okay.
Soon we will transfer to
next
GUI.
Yes, of course.
Because I know most of the people waiting for the graphic.
Yes, that is one thing that we should do it as soon as possible. The other thing is, this protocol here lacks a lot of things.
Yes.
For example, for sending an object to the other side, we are using this pipe as the separator, which is very naive. For example, nowadays everyone is using for example, JSON or XML, especially JSON for serializing an object and sending to the other side. They are using JSON, and we have to use it as well. And also we will convert this protocol to the HTTP. And yes.
Okay. Thank you.
Thank you.
That was useful. Thank you
you
guys for watching and supporting us.
See you next session.
Bye bye.
Bye.